When we have a triangle and we draw a line anywhere through the triangle, like this, and that line is parallel to kind of the line across from it, the line it doesn't touch, we create similar triangles. And if I can just explain here why, let me kind of extend my lines here a little bit. Like this. What has happened is that we have same side or corresponding angles that are the same. These corresponding angles are the same. And then obviously these two triangles share a vertex. So we have one triangle, the big triangle, this one right here. And it is similar to this smaller triangle right here. And again, that's if we create this parallel to the other side, because then we have created these corresponding angles. And remember, one of our ways to know that triangles are similar is they have congruent angles. And by our properties of parallel lines, these do. In fact, they by necessity have all three that are the same. So what this gives us the ability to do when we have a situation like this is to solve for missing parts inside our two triangles. Let's do an example. All right, so I've drawn a slightly different triangle this time. And again, let's just think about the fact that because of this parallel line right here, it creates two similar triangles. This triangle in green, and I'll do another one. Let's do the other one in red. This big one right here. Okay, and these are going to be similar because of that those parallel line cut by a transversal properties. Now, one of the things that can kind of be tricky about this is there are a lot of proportions that are going to be true. For example, we learned that we could create a proportion where we say like 5, the one side of the smaller triangle, 5 is to 9. And I'm getting 9 by saying 5 is to this entire thing. Well, if this is 4, then this is 5. That is equal to 6 over 6 plus x. That's a proportional relationship that would have to be true, that the small over the big. And, we can easily now solve this with cross multiplying. We can take 5 multiplied by 6 plus x, and we just got to make sure to multiply the 5 by both of those things. So 5 times 6 is 30. 5 times x is 5x. Of course, we go the other way. 9 times 6 is equal to 54. Subtract both sides, or subtract 30 from both sides, so 5x equals 24. Divide both sides by 5. So x is equal to 4.8. Now, one thing I want to point out here is I solved this in kind of a logical way to me that I thought, how we've always set this up is kind of the smaller is to the big as the smaller is to the big. But there are other relationships you could do. You could have done, 5 over 6 is equal to 9 over 6 plus x. You could have set it up that way. But one thing that's different about these problems is these relationships also hold true with kind of the individual pieces. And what I mean by that is that instead of relating 5 to the 9, the entire side, I could have just related 5 to 4. I could have said, well, 5 over 4 is equal to 6 over x, like that. I could have just done the pieces, and you'll see when I cross multiply those that 5 times x is 5x, 4 times 6 is 24. You can see I'm at the same exact spot. So it's one of the kind of interesting things about this particular relationship of similar triangles is you actually can just do the pieces. It depends on what you're really given and what you were solving for. Like in this example, where all I wanted to do was find x, I would have opted to do it this way. Now, you're going to get the same answer either way, but I just think would have been easier, would have been able to have an easier cross multiplication. Now, on the other hand, if you said, well, no, I want to know the entire side length, well, then, yeah, you'd probably maybe want to go at it this way. But either way, I guess the whole side length, you just add 6 and 4.8 and get 10.8. So you have options when you're creating similar triangles by a parallel line to one of your sides. If this video helped you, please like and subscribe for more geometry help.